right, it's January 25th, and we are getting ready for class. Morning. Alright, let's see if we get the infinite feedback loop, which means the screen's working, and then I'm going to have to shut off my screen. Here we go. Go. There we go. There we go. All right, we'll keep streaming through YouTube, and I will turn off my streaming so we don't get the inception effect. And I will turn off my streaming. All right, good morning, everyone. I'm going to switch over to in-game audio for a sec.
Yeah, I'm here. I'm here.
I'm here.
I'm here. You're here. Here.
Morgan?
Here.
Here.
Hello.
Here.
I'm here.
I'm here.
Here.
Good morning, Professor Patterson.
Can you hear me now, Dr. Patterson? Can you hear me okay? Can you hear me now? Oh, sorry. I'm connected. Not using AirPods. Sorry, I'll figure it out.
Yeah, it should be working fine.
switching. I'm on YouTube and in game. Now I'm just on YouTube. Okay. Some of you have raised the concern that in the gradebook there are a bunch of zeros for things that aren't due yet. Again, that's because for some reason Canvas put the due dates by default in summer of 2018. Never taught the class then. So I'm going through and adjusting some of those. I think I've put all the due dates in the right spot now, but I'm not happy with where things are falling out with our new schedule for this semester. If you are a first year student, you're not kind of aware that this is a new schedule, but we're operating under a new schedule to accommodate COVID travel concerns, to reduce COVID travel capacity, actually, so that we don't spread the virus unnecessarily on campus. But that has thrown some of the original scheduling for a loop. So what I'm planning on doing is reducing the amount of time we spend on some of the introductory topics, for example, loops and decision making, things that are pretty similar to what we've seen in Python already. And I want to extend some of the time we spend on more sophisticated data structures, the kind of things that I kind of think are more important in this class. Also give us more time to work on our drone scheduling assignment later in the semester. So all that is to say is that some of our due dates are going to shift as I get that stuff ironed out. All right, as a reminder, in class, there are some solutions to problem set 1 located over on my avatar's right on the bookshelf. Has anything else happened in game yet? I don't think anything else is different in game for the time being. I'm broadcasting behind me, but I guess you know that now, or you're not listening to anything. And I think we're ready to go with content. Any comments or questions before we get rolling? I feel like there was something else I needed to say, but it is eluding me at the moment. All right, let me give you a second to ask any questions. I'm monitoring audio in game and I am monitoring chat in game. And while you think of any concerns or questions that you have, I'm going to bring up our slides. Okay. All right, I guess we're ready. All right, let's do it. All right, so in Eclipse, we've been making objects of various kinds. Here's my Eclipse environment for today. I have a project set up over on the left for class 6. If you're watching on YouTube, I just want to remind you that you can increase the quality of your presentation by hitting the gear button on the bottom right and increasing the resolution of the video if you can't see stuff because of the resolution. So on the left, I've created a project for today by going under File, New, Java Project and working through that. Notice that I do not have a file in my project here that says module-info. That glitched some of you all on the first programming assignment. I went ahead and deleted that. I have a folder called SRC that is both a folder on my hard drive, but it also has the designation in Eclipse that for my project, this is where I'm keeping my source code. So it's two things. It is a file on my hard drive. It's a folder on my hard drive, but Eclipse has also designated that folder as a place that's going to hold my source code. I don't have any source code, so let's fire up a new class here just to give us a place to work from. So I'm going to create a new class and we'll just call it demo for today. I'll go ahead and give it a main and I think that's it. All right, and just to make sure everything's working okay, I'm going to remove the to-do comment and I am going to show you the code I'm writing. And I'm just going to do a hello world to make sure that everything is, all the plumbing is set up right today. And I'm going to run that. Here's a shortcut you can do. If you highlight your main function like this in the editor and you right click on it, you actually can go down and run that main function as a Java application. It can be a little bit shorter and it's very explicit about what it is you're running. All right, so when I run that on my console, I get a good morning and everything's good to go. All right, previously we talked about the way in which a public interface is defined. And we said that public interfaces are those methods and instance variables that API programmers are supposed to use. So people that want to use my demo class are allowed to use those methods and instance variables that are declared as public. Those methods that are declared as private are for the internal use of the object only. They're private methods. This is enforced by Java by using the keywords public and using the keywords private. We also saw this word static, and I was thinking a little bit about how to describe this because we don't actually talk about static stuff until much later. But because there's going to be some code that can be a little bit confusing if you don't have some idea of what static is, I want to give you an idea of what static means. In Python, we can just write code linearly in a file. We can just, at the top of the file, we can just assign variables values, we can print stuff to the console, we can add things, we can do whatever we want. In Java, we have to put everything in the context of an object, and so we use the main method as the place where our programs launch from. Every class can have one main method, meaning that you can launch a program from any class that has a main method declared. A class does not have to have a main method declared, and you only need one per project for it to do anything if you want to launch from there. If you'll recall in Python, when we were developing the architecture and the layout for our programs, I encouraged you and in some cases required you to have your Python program only have one line of code that gets executed, which was the call to the main function at the bottom of your file. That call to the main function would then run a main method or a main function, and then everything would kick off. That was to help introduce you to the idea of the flow in Java for the way that Java works. And in fact, many other programming languages work as well, where everything starts in the main method. Okay, that's great. That doesn't describe static though. So what I want to give you is just a 10,000-foot explanation of static. A static method is one that is run as if it is outside of the object. So this code, it exists inside the demo object, but it actually doesn't have access to any of the instance variables or any of the private methods that are within the demo class. So it's almost as if there's a little chunk of code that's labeled static that is like Python code that isn't in an object. And let me give you a little example of this in the code that I have on the board. All right, so here's an example of a private method. It will return an integer. I'm just making this up, and we'll call it helper, and it will take nothing as parameters, and it will return a 1. All right, it's not doing any work, but what I want to do is I want to demonstrate that I can't call helper from my static method. I get an error there, and if I hover over it, Eclipse says, cannot make a static reference to the non-static method helper. All right, this is because two reasons. One, it's a private method, and the static code exists kind of conceptually outside the body of it. It travels with the class, but it doesn't have access to the elements of the class. It sort of exists outside of it. Similarly, if I create a public method, this would be something that an API programmer could use. And let's say it's going to return an int, and we'll call it mystery, takes no input, and it returns a 2. I can also not call mystery from my static method. This is because, again, the static method doesn't really have access to an object by itself. It is not part of the internals of the class. It exists like inline code in Python. Now, if I did want to use these within the main method, if it's static, as all main methods are, I would need to do a little bit of work. What I would need to do is I would need to act as if I was outside of the class, and I would need to create a new object, and we'll use the new command to do that. We'll call the constructor for this object. The constructor in this case is implicit. I didn't have to make one. I could have made one, but Java will give you a basic one that does nothing automatically. And I've created a new object here, and what I would like to do is I'd like to capture a reference to that object in a new variable that I'll call my demo. All right, so what do we have here? We have a variable called myDemo. It is of type demo class. It has been created by calling the constructor, which we invoke by using the new reserved word and calling the constructor itself. In this case, the constructor is implicit, but let me go ahead and create a constructor just so that you can see it. And I'm going to use some of Eclipse. I'm going to use some of Eclipse's code helping to do this for me. Okay, here's an example of a constructor. It does nothing, but it's now defined explicitly so that you can see what it does. All right, now that I have created a demo object, stored a reference to it in a variable, now I can do something like, say, system.out.println, and I'm going to print out the result of calling my demo mystery. And let me break this into 2 chunks for you so you can see what's happening. All right. I'm going to smush all the code together so we can get it all on the screen. I recommend putting space between your methods, but for the purposes of teaching, I'm going to try and keep it tight. Okay, now I'm going to right-click on main. I'm going to go down to run it as a Java application, and you can see that we run this code as if it was outside of the body of our object because it's static. We print good morning. Now we create an instance of this class called demo. We store a reference to it here. Now that we have a reference to an object, now we can call it as if we are a API programmer, as if we are using the demo class. We'll call the mystery method by using the dot notation to look into the reference to that object, store the result in a new variable x, and then output it to the command line. We can see 2 here. As I look in my code, I see Eclipse is giving me a warning. It's saying, hey, the method helper from the type demo is never used locally. That's a warning that Eclipse is giving me, telling me I'm probably making a mistake because I've created a method that's never being used. So to help resolve that, let's just use within the body of our mystery method, which is part of our public interface of our demo class, we'll call that helper method internally. We'll just add the result twice. We should get the same result. Call helper and helper within the body of a class. If you'll recall, we had the self reserved word in Python in order to refer to the reference that reference for the object that we are interested in. In Java, we use the this reserved word, and it's optional if you're within the body of a method. All right, so I'm going to run this, and we can see that the result is that we see good morning, we create a demo object, we call mystery, mystery calls helper twice, adds those results, 1 + 1, and returns that here. All right, so we're going to walk through and deconstruct that a little bit in some slides. Are there any questions that you guys want to ask about that before we go into the slide deck about it? All right, I'm monitoring chat if you got them. All right, so for our method declaration, to declare a method in our class, we want to specify the input and the output of that method. For us, the input of that method are the parameters or the arguments that we pass in. In the example that I just showed you, both helper and mystery had no arguments because they just had an empty argument class. And the output of a method is the return value. And again, that's different than a side effect that might also be present within a method, which is some effect that it has. For example, putting something on the console is an effect. Writing something to the network is an effect. And that's different than a return value that we use as part of the flow of the code. When we look at a declaration like public int length, like we've got here, there are no arguments and the return value is of type int. Here's a different example. This is an example of the declaration of a function of a method called replace. It is a public method, meaning it is used by the API programmers. It returns a string, as you can see because of the string declaration here. It takes 2 inputs. It takes one input that within the body of the method we'll use the name target to refer to it, and we'll use the second argument is called replacement. We'll use that within the body of the method to refer to the second argument. Both of these are of type string. In the second example here, we have one input, which is output, we have one input, which unfortunately is called output. It is of type string. We have no output. The method itself returns has to declare what it returns, and if the method chooses not to return something, it has to explicitly say that it's not returning something. And so we put the word void to indicate that it doesn't return anything. This is similar to the none reserved word in Python. Nevertheless, this is part of the public interface, and it is called println. No return value. We use a keyword void. Takes an argument called output. All right. A class within an object, we can actually have multiple versions of a method that have the same name, and this is called overloading. And we might want to do this in order to provide similar functionality for different argument sets. And so here's an example. Println actually has a different println method, which takes as input a integer, in this case called output. Our previous version took a string as an input. And so there are two different versions of the println method within the printstream class, and they take different inputs. You can have as many versions of a method as you would like, as long as they have a different signature. And that signature means a different set of return values and arguments. All right, so quick checks. How would you compute the length of the string Mississippi? Well, you could either use a variable or you could use the string literal, and you would call the method length on it, and you would do that by using the dot notation to look into it, to look into the method that's in the class to get the value of the string's length. We can either use a variable like here and do river.length, or we can use the string literal itself and then call .length on it. If we wanted to print an uppercase version of the hello world, we would use the uppercase method. Again, we could do that on a variable, or we could do that on the string literal itself. In this case, what we've done is we have chained it together. The result of the two uppercase method is being passed directly into the println command so that we go right to the output immediately without storing it in some intermediate variable. Can we call river.println? The answer is no, we can't do that, because if assuming that river is a string class, the println method is not a method of the string class. The println method is a method of the printstream class. River is not of type printstream, and so this is going to give us an error. We would need to do something like system.out.println and pass it as input river. All right. In this example, river.replace p, s. If you recall from our previous lecture, we used the replace method, which is part of one of the methods in the string class, in order to replace occurrences of the first string with the second string. So for example, we converted Mississippi to Missouri by using this. So when we look at this, being able to parse this and understand what the different components are an important skill. And so one question you might ask is, what are the arguments to this? The arguments are the inputs to the method. And so in this case, the arguments are the P and the S string in this case. Two arguments. They help to address and adjust how a particular method works. If we wanted to call this method with those two arguments on the string Mississippi, we would get a particular result. We would replace the P with the S, and we would get the string Mississippi. And there's a little bit of ambiguity here about what exactly replace would do. You could imagine that what replace might do is it would replace just the first instance of P with S. And what we see here is, in fact, what replace does is replace all instances of P with S. And the only way that you know what it does is by looking up in the documentation how it actually works. And actually, Eclipse is really good about doing some of this work for you just through inline tooltips. Let me see if I can get this one to work in the case of replace. Let's see if I can show you what I mean by that. So switching over to Eclipse and taking a look at that. Here is an example. Here's the code that we just had. Let me introduce a new string. I'll call it greeting, and I will use the good morning down below as our example of the greeting. I'll put a new line character at the end, so when we're done printing it, it prints to the end. Actually, I'm going to get rid of that new line character because println implicitly has a new line character. And I'll pass in greeting there. All right, so I might want to replace morning with evening, and so I might want to use the replace method, and I don't recall exactly how that works, so I might do greeting dot, and as soon as I hit the dot, Eclipse is going to help me and try and find all the different things that I could possibly mean by that. So I get a long list of everything that might be relevant. And as I start typing characters, that list will get filtered according to what I've typed. So I'm just going to type replace and see what I get. You can see that there's a lot of methods available. One is called repeat. There are two that are called replace, and you can see that they're overloaded. Like we just discussed, there are two versions of the method called replace that have different inputs to them. We have another one called replace all and another one called replace first. And if I go down here to char sequence is a more recent version of the string type. So let's go down here to char sequence. And what I get is over in the gray box to the right, I get a little description of what it's going to do. And I read that, I slow down, and I read the tools, what the tool is telling me. And it says, what this method does is that it replaces each substring of this string that matches the literal target sequence with the specified literal replacement sequence. And I look and I see that over in the left pop-up box, the first argument is called target and the second one is called replacement. The replacement proceeds from the beginning of the string to the end. For example, replacing AA with B in the string AAA will result in BA rather than AB. So you can see that there's some complicated ways in which you could understand replace, including when there are multiple matches within the string. But the main thing that I was looking for is that it's going to match all of the substrings. And so when I look at that and it says replaces each substring, I know what it does. Now, contrary to other things that you might be reading on the internet, the documentation for Java is very, very specific. It's like a mathematical proof. It means exactly what it says. And so it's not like roughly or this is kind of an idea. The Java documentation is very, very precise because we can't have people writing code where we sort of mean replace and then sort of it messes up in corner cases. It's very precise. And to someone who's programming, you need to be very precise to meet all those corner cases. So what I'm going to do is I'm going to replace any occurrences of good with, any occurrences of morning with evening. Go ahead and end that with a semicolon. Right click on that and then run it as a Java application and it should show up on the bottom. If I don't have any errors. Oh, it failed. It failed because what it does is it returns the answer. And while I did call that method, I didn't actually capture the result. So let's capture the result. So I'm going to store the new result replacing what was previously there. So what you just saw there is a reason why you should always do testing. All right, now it says good evening. Great. All right, questions or comments about that? I'm gonna just pause for a second and see if there's anything that you guys want to unmute for to talk about. And I'll switch over to in-game audio for a second. All right, so the question was The question was, talk a little bit more about this typing here of this particular line and how we're using this line. All right, if in the case of Python, you might have had something where you defined a class, something like this, and then down here, you might have done something like this. You might have created, well, let's see, in Python, it would have looked like this. You would have had a variable, you would have just set it equal to the constructor, there wouldn't have been a semicolon. So a couple things have to happen for us to be able to use an instance of the demo class. First of all, we need to be able to create an instance of that class. So we have the class, it's a recipe, we need to create the actual cake from that recipe. We have a cake recipe, we want to make the cake. So the way that we do that in Java is we don't just call the constructor, we actually say new, and then we call the constructor. So this communicates that we want a new object. We're explicitly saying that. We need to put a semicolon at the end. That's the nature of Java, because Java doesn't do indentations. And so instead of looking at indentations, Java looks at semicolons. This is a variable, so that's okay. That we know about variables. That should be capturing a new class. That's not a problem. Java, however, requires us to explicitly declare a variable before we use it and what type it is. So we have to do something like that and say we're going to have a variable called myDemo, which is of type demo class, and then we can initialize it. So in this case, I'm doing it in 2 lines. Now in Python, this was fine. We would have a file. We would declare our class here. We do it slightly differently, but we would declare our class, and then down here we would have some code where we actually run it. We create it and run it. Java, we can't put any code outside of a class, and so we have to put it somewhere in our main method where we launch from, and so that's why we put it up here. So let me do indentations just for the purposes of reading, not because Java cares. Let me replace these because that was for a different example. And let me just remove this for a second. And so just to clarify, when we're in the main method, it's similar to as if we had just put the code down here below in Python. This is a place where we can put code that's just running kind of independent of any context, but travels with the demo class nevertheless. We have a new variable name, we have the new type, and then this is just a reference. And if we actually want to give it something that it's referring to, we have to call the constructor to make that chunk of memory and store it there. And we can do that all in 1 line if we want, just by getting rid of that. So does that help at all? All right, kicking back to YouTube. And wow, okay, there we go. Okay. All right, let's move forward through some of these. Okay. Turns out that there are a lot of objects that are defined within Java automatically. One of them is the rectangle class, but we can also think about making our own version of the rectangle class. Now, as we talk about this as an example of making a class, what we're talking about is we're talking about an abstract idea of a rectangle. We're not actually going to draw it anywhere. We're just going to keep track of it, and we can use it in other contexts if we care about it. Oh, thank you. We're not going to keep track of it. We're going to keep track of rectangles for other reasons, perhaps, but we're not actually going to put it within the context of a programming or something. Yeah, sorry, I was doing double audio. I forgot to turn off in-game audio. Okay, so a rectangle object, it is not a rectangular shape. It's just an object that's representing it, right? It's not a drawing or anything. It is a data object. And so we're going to have some instance variables in this case. It's going to have some numbers that define it. We're going to put its position somewhere. So we'll talk about the upper left position, be it in an X and Y location, and we'll give it a width and a height. So we can create multiple instances of rectangle objects by calling the new keyword and constructing 3 of them. Here are 3 visualizations of the rectangle object. Red meaning we've created some space in memory to store them. 4 instance variables in each one of them. They each have the same name, but they contain different data. So for example, if we look at X, the first one has a 5, the second one has a 35, the third one has a 45, and so on with the other variable IDs. We're going to call our constructor on the rectangle class with the new reserved word like we saw in the demo, and we'll pass it the 4 arguments to its constructor, which is the X and Y position, 5, 10, and its width and height, which is 20 and 30. That new operator is going to create that red chunk of memory for us, and those parameters are going to be used to initialize our object. And what the new command does is it returns a reference to that data. So like when we talk about the return value of new is the object itself. This process is called calling the constructor, or it's called construction. 5, 10, 20, and 30 are the construction arguments or the constructor's argument. And usually we're going to grab that reference right away and store it in a variable. For example, down here where we have rectangle box. So we have a variable called rectangle. Sorry, we have a type called rectangle. It is a class because it starts with a capital letter. The variable is lowercase b box, and that is we're going to store a reference to this new chunk of memory that we create by calling the constructor. We can call the constructor again right here, but in this example, we're using a version of the constructor that takes no arguments, and we're not doing anything with the reference. And so that's not actually, I don't know what we're hoping that it's going to have some side effect that we care about, but we're not storing that value anywhere. All right, so object construction consists, sorry, this is so small. Wish I could make it bigger easily. Let's see. I can make the text bigger, but not the pictures bigger, sorry. Okay, anyway. We just looked at what we got there. We can use that if we want. All right, so if we wanted to construct a square that has center 100, 100 and a size 20, we could use the rectangle object and just make sure that its width and height are the same. So the reason why we say its center is at 100, 100 is because the first two arguments in rectangle are the upper left corner. And so they need to be 90, 90, so that a square that has a width and height of 20, 20, the center is halfway across. So halfway across 20 is 10, and halfway down from 20 is 10. So the center of our rectangle is going to be at 100, 100 if the upper left of our rectangle is at 90, 90, and it is 20 and 20. This kind of detail you need to pay attention to in Episteme 2 in the programming assignment. When you are creating a window that has the spiral image in it, you'll need to do some math in order to make sure that the image is located at the center of the window. The process is very similar to this example here. So in self-check 2.21, you see some of the nugget of the knowledge that you need in order to get 100% on your Episteme 2. All right, we have multiple references, so we can initialize two variables, box and box2, with two rectangles that touch each other by calling the constructor twice with the appropriate parameters. So the first line creates a variable called box, and the second one is box2, both of type rectangle. We're creating two instances of rectangle, so two chunks of red memory, but the variables are going to be initialized with different values. Be 5, 10 is the position of one, and 25, 10 at another. The first one is 20 across, and so if we think about that, our first rectangle is going to extend on the x-axis from 5 to 25, and on the y-axis it's going to extend from 10 to 40. And the way I got that was by taking the x and y position and adding the width and the height to it. So we know that if our first rectangle extends from 5 to 25, we can create a second rectangle that starts at position 25 at the same height, 10. And so our second rectangle will extend from 25 to 45 and will be next to the first rectangle. Both those rectangles will have the same width, both those rectangles will be the same height, but because they have a different x coordinate, they are next to each other. Like good neighbors hanging out next to each other in box world. They are actually rectangles because they have different widths and heights. Okay, Happy Valley. All right, get width is a method that exists within the rectangle object. That's an assumption of this question. And so the question is, what does the following statement print? New rectangle dot get width. Well, this is a little tricky because we're calling a constructor. And when we call that constructor, we get a chunk of red memory with variables filled out in some way that depends on what the constructor is going to initialize them with. Without any other information here, what you should assume is that all the variables get initialized to zeros or none or empty strings. And so this example, what you would assume is that x and y are 0 and width and height are 0. And so you would assume that when you get a width back from a rectangle in which you haven't provided any arguments, you would get some sort of default value, and 0 seems reasonable. To know that for sure, you would have to look at the documentation for the rectangle constructor because, a rectangle could be initialized with some particular sized rectangle depending on the particular application. But a good guess is that it's 0, null, empty string, that kind of thing. All right, that's enough self-checks. Let's move forward. All right, as was the case in Python, we can talk about methods being of two types. They can be accessors or mutators. Accessors are those methods within a class that return information about the state of the class. Typically, they return values of the instance variables that are present in that class. So we often call them getters as well. Mutators do something that change the instance variables, that change the state of the object, and we call them mutators. Sometimes we call them setters, although in general, mutators can do more than just set variables. They can do sophisticated different changes. So an example of the accessor method for the rectangle that would get information about the state of the object but not actually change it would be getWidth. We'll use that on some instance of a rectangle, for example, box, and we get the width back, and we'll find out what the width of a rectangle is. That looks into an object using the public interface, not going directly into the private instance variables, but using the public interface to find out what the width of our box was. The string class, if we use the length method, that's an example of an accessor. Accesses information about the state of the string. A mutator method is going to change the state of the object. So an example of a mutator method on the rectangle object is translate. What translate does is it moves the upper left position from one point to another point. So if we do box.translate 1525, those are deltas, so they are something that we're going to add to the x and y position. And so wherever the box originally was located, it's now going to be moved right 15 and down 25. So if our original position was 510, after calling translate, the box will be at 2035. We didn't change the width or the height, so the shape will still be the same. It's just the position will be different. This is an example of a mutator because by calling this method, we have changed the internal state of the rectangle. All right, let's take a look at a few of these to make sure that we can work through them. What does a sequence of statements print? Well, the first one is going to create an object for us. It's going to create a new rectangle, a reference called box, initialize it to position 510 and width 20 and 30. We'll call a getter, which is getX. That's going to return the instance variables x position. So we expect that the first one is going to say before 5, because our x position is 5. We're then going to translate our box, mutating the value of the instance variables within the box, so that we expect that the same method call, getX, called a second time after the mutator method has been called, will return a different value. Since translate is going to move our box 25 units to the right, we would expect that the new x position would be 25 plus 5, the original position. So I would anticipate that this would say before 5 and after 30. And I could run it and I could see that as well. Let's do this one. Here's a different class, also a mutator. If we take the string hello and we print out greeting to uppercase, we would anticipate that greeting to uppercase would return a version of the string with all the letters capitalized. Now again, you saw from my example when I was working with Eclipse that this isn't actually a mutator. This doesn't mutate the internal value of the string. What this does instead is return a value of the string in which the characters are uppercase. So it returns a different version. So there's two strings. There's the greeting string, and then there's the string that gets returned by the to uppercase method. We use that only to drop it in as an argument to println, and then it goes away. It gets garbage collected. And the important thing to notice here is that even though we call greeting to uppercase in the second line, which will print out hello with capital letters, in the second case, greeting hasn't been mutated. It should stay as lowercase. So the first one will be capital letters and the second one will be lowercase letters. That's because, like other languages in Java, a string is immutable. Once you have a string, you can't change it. And the way that you change it instead is by returning it from some sort of transformation and then storing the transformation. Okay, that's good for self-checks there. Let me pause for a second and see how we're doing on comprehending right now. Switching to in-game audio. Check, check, check. Check, check. Okay, back on YouTube audio. And what we need to talk about is a little bit about the API documentation. So I said that in order to know what these things do, you need to look at the API documentation. You can have a quick check on the API documentation by using the Eclipse context tools. So if you start typing a class, sometimes you can get the methods that are in that class by hitting a dot, and you'll get an example of Eclipse replacing Eclipse replacing the method, shortcuts. I don't know, what do you call it? It's like text. It's like completing your sentences in a text message or something, but it's doing that with code instead. However, the formal documentation for Java is held by Oracle. So if you want to go out to a website and you want to check what the formal documentation is, you can go and you can look, do typical Google search. But what you would do is you'd look up the documentation for a particular method. Now, the thing that you have to be careful of is you have to be worried about two things when you do this. Thing number one, just because Google gave you an answer doesn't mean it's the right place. You have to know that the right place to go for Java documentation is oracle.com. Oracle has the intellectual property rights for Java, and so they maintain the authoritative documentation for Java. Thing number one, the authoritative documentation is located at oracle.com. Thing number two is you have to make sure you're looking at the right version of the documentation. You could be looking at the documentation for a version of Java in the past or in the future, and you can get the wrong answer because the documentation and the methods change, not drastically, but subtly over time. And so if you have a question, you want to make sure you're looking at the right one. So let's on the screen that I'm broadcasting, let me bring up a Google window if that works, right? All right, let me just sort of demonstrate what that might look like. We want to look up the documentation for the rectangle class. So we're going to, maybe by default, we might say Java rectangle class. See what we get back for results. When I look at this, what I'm looking for is a couple things. I'm looking for the links that are at Oracle. So I'm looking for that. And then I'm looking for making sure we have the right version. So version 7 is not what I'm interested in. I'm interested in version 11 because that's what we're working with right now. So I'm going to click through on that. I'm going to make sure that I landed there. So I'm going to make sure in my URL bar, I'm actually looking at oracle.com. I'm going to make sure that I've got version 11 either in the URL or somewhere on the web page, presumably both of those places, it would say 11. And then here what I get is the formal documentation for the rectangle class. It's really quite elaborate. And for those of you who are at the point of understanding what I'm talking about, this is all automatically generated from the comments in the source code for the rectangle class. It's generated from JavaDoc, which is the markup language that you can put in your comments. And so what do we see here? We see that the rectangle class is located in this package. So if we want to use it, we have to import that package. We can see the inheritance hierarchy. We haven't talked about inheritance in Java, but we have inheritance just like in Python. It inherits from object, rectangular shape, rectangle 2D, rectangle. A couple things about interfaces we haven't talked about, but then we see a definition of the whole thing here. Rectangle specifies an area and a coordinate space that is enclosed by the rectangle object's upper left point and its width and height. Bunch of other description about how it can be used and how it's intended to be used, some ways in which you can use it in the context of a loop. Come down here, you can look at what the different fields are, and what I'm interested in is the constructors. Here's some examples of all the different ways in which the constructor can be called. And you can see that, in fact, this rectangle, the one in version 11, has 1, 2, 3, 4, 5, 6, 7 different versions of the constructor. All of those versions of the constructor are overloaded. So one version takes nothing, and you can see that it is initialized like we saw to 0, 0 with width and height of 0. Or we can initialize it with just a width and a height, in which case the upper left corner is assumed to be at 0, 0. Or we can provide all four. Or we can use some other classes that have similar information. There is a class called dimension, which captures width and height within it, or a point, which captures x and y within it, or a combination of those two. And you can look up the documentation for those by clicking through on those classes if you'd like. Or you can initialize a rectangle based on another rectangle. So a lot of different options for ways that you can do it. You might want to know a little bit about the translate method. So I'm going to search on the page for translate, and I'm going to see what translate does. We use that. I see that it takes two parameters, two integers, dx and dy, and it says translates this rectangle the indicated distance to the right along the x-coordinate axis and downward along the y-coordinate axis. It's a quick answer. If I want a longer answer, I can click on that method and get a more elaborate description of that method. So the thing is that every single method in the Java library classes are described like this. And you can see them all through this documentation. There you go. These are all the classes that are present within the Java standard libraries. And it just goes on and 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 on. It's long and it's elaborate. And this is why I said earlier that's not something that you memorize, right? It's something that you look up and you learn. You learn sort of how programmers think, and then you kind of know where to go to look for stuff. All right, so that's documentation. Any questions about documentation? Throw them up there in the chat. We just went through browsing that, so some slides about that in particular. I mentioned briefly that we have this concern with packages. Packages are the way that we include code from other libraries. It's like a module in Python. All similar things are grouped into different packages. And the rectangle class in particular, as we saw in the Java documentation, is in a package called java.awt. And the reason why you have to be careful about your package is because anyone can declare a rectangle class. And to make sure that you're getting the rectangle class that you expect to get, you have to make sure that your import statement points to the correct rectangle class as well. This is a line that you put at the top of your program, but some classes you get automatically because they come from the java.lang package, java.language. The java.language package is implicit. That's always assumed to be present in your packages and your programs, and that's why we didn't need a specific import statement for string and why we didn't need a specific import statement for system when we were printing things out, because that's part of the Java language package, which is assumed to be part of what we're working with. So let's take a look at what that would look like to work with a rectangle class. And the way I do it, I don't like to monkey around a whole lot with those classes, so I prefer to have Eclipse do the work for me. So let me get rid of my constructor, let me get rid of my private and public interface, and let me just use the main method as a place to run some code. And what I want to do is I want to use the rectangle class. So I'm going to create a variable of type rectangle. I'm going to store a reference to a rectangle in my R variable, and you can see that Eclipse is giving me a big old red warning. The big old red warning is because Eclipse doesn't know what rectangle class I'm talking about. I have to be specific about what rectangle class I'm talking about. If I hover over this, I'll get that information. Rectangle cannot be resolved to a type. Eclipse has very powerful assistance, automatic assistance. So if I hover on this, or in my case, if I hit Command 1, Command 1 will bring that up automatically as well. But if I hover over it, I get a bunch of quick fixes. Different things that Eclipse says, hey, maybe this is the solution that you want. And as I look down, there are a bunch of different possibilities here. One is to import the rectangle class from java.awt. Now I know that's the one I actually want, but let's look at some of the other ones. The second one is, hey, maybe you want to create your own version of the rectangle class. Maybe that's what you want to do. In that case, it will create a skeleton class for you called rectangle. That's not what I want though, even though that would fix the compile program. You can also see down there in like lines 3 through 6, it says, hey, maybe you didn't mean rectangle, maybe you meant rectangle 2D, or rectangular shape, or rect size. All of those things would also fix the problem, but they would fix the problem in the wrong way. So just like panic searching on Google is not going to get you the solution that you want without understanding what the solution means, also just panic taking Eclipse's solutions are not going to be the right thing unless you know what it wants, unless you know what it's offering you. The best way to use these solutions is to use them to write code faster for you, not to fix your problems. So when I write code like this, what I'll do is I'll write rectangle, knowing very well what rectangle I want, but I won't bother typing the code for package because I know Eclipse is going to recommend that for me, and it's faster for me to take the solution, the automatic solution. So I'm going to click here. And when I do that, you can see that what Eclipse did for me is automatically import the correct rectangle. If there were multiple options, if there are multiple rectangles that I could have used, Eclipse would have asked me, which one do you want to use? In which case I would have to be familiar with them in order to know what it is I wanted. Now that I've got that, I've got a warning on my R, a yellow warning, which says, hey, you might have made a mistake programming because you're never actually using that R variable. So that means that there's some sort of intention error for you, Mr. Programmer, Mrs. Programmer, Ms. Programmer. So here, I want to use it. I'm going to create a new rectangle. It auto-completed too fast. I'm going to say it's equal to a new rectangle. And what I know about rectangles is a little bit about how the constructor works. And let's go ahead and use one that's 5, 10, 20, and 30. That'll call the constructor. And then I'll go ahead and print out r.getWidth. I'll do get height because that was faster on the code completion. Give Eclipse a second to color code everything. Show me that there are no errors. Hover over main. Right click, run as Java application. Save my code. And then you can see that I get, can you see? Yeah, you can see that I get a 30 down there on my console. All right, so packages are the way that we import things. It's actually much easier in Java in order to import things. The other thing that you can do, and I do this all the time, is like if this wasn't here, there is a line under source that says organize imports, and it'll just go through and add them all for you. It's so much easier. It's unbelievably easy. So much easier. I love it. Okay. Okay, importing a class from a package. We're running out of time. Let me make sure there's nothing else that I want to make sure I hit for us this time. I guess the last thing I want to talk about is make sure we understand we're talking about references. Just like in Python, when we create an object, we're creating a reference to an object. So a variable, for example, of type rectangle is a reference to that object. And so the variable itself is just a pointer to a chunk of memory. And so I'm not showing you the slide, sorry. The variable itself is just a pointer to a chunk of memory. And so we have to be careful about, for example, having multiple references pointing to the same object, same issue we had in Python. If that's what we want, that's fine, but that aliases our two objects along the way. This was an example. We've used this several times now. Box is a reference to that chunk of memory that we've created. Doesn't actually contain the object, it contains a reference to it. And so if we have an example like this, where we create one reference to a rectangle, call it box, we can create a second reference to the same object, give it a different name, but they're both pointing to the same chunk of memory. And so we could change the rectangle that they're referring to either by accessing box or by referencing box2. If what we had intended was to have two separate chunks of memory, two instances of rectangle classes, two cakes instead of one cake, we would have need to use the new command twice to create separate rectangles along the way. And this is the difference between primitive numbers and object numbers. Numbers are not objects. The primitive kinds of numbers are not objects. They actually store the number in them. And so it's not possible to have two primitive things pointing to the same number object. And the difference is when we copy a number, when we copy a primitive type, we're really not working with references. So this is a tricky part of working with Java. It's just something you have to know, that primitive types are not references, classes are references. And so maybe what we'll end with is an example of that. If we want, let me switch over to Java. And we look at this and we have a rectangle. I'll create two references, R1 and R2. I create R1, that's a reference to a rectangle. And now I say R2 equals R1. Both of them are pointing to the same object. I look at the X position of R1, and then I change, let's translate that by 10, 10. I will end up changing the position of R1 by using the translate on R2, because both R1 and R2 are referring to the same object. So if we run that, we will see that the translate should affect R1. Great. So the first time we print out the position of R1, that's 5. Second time we print out the position of R1, that's 15. That's because even though we translated R2, R1 and R2 are both references to the same object. Compare that here to I1 and I2, which are integers, and we say I1 equals 10. and we say I2 equals I1, if we say system.out.println, I1, and then we say I2 equals I2 plus 10, and then we print out I1, it will not change along the way. Let's verify that. All right, so here's the example of our references in which changing R2 does change R1, and here's an example of primitive types where changing I2 does not change I1. And the difference is just that they're not references, and there's no way to know that other than understanding how Java works and understanding that a lowercase letter indicates a primitive type and an uppercase letter indicates a class or a reference. Okay, that takes us to the end of our time today. Thank you for bearing with me. Let me switch over to game and see game audio and see if there are any questions. If you have no questions, you are free to depart. Thank you for your attention. Check, 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 check. All right, that wraps up class for today. January 25th, CS-030, wrapping up chapter 2. And we're heading back.